Okay, we will continue our lecture how to access different rows and columns. Because it is very important applications when the data file is very big, sometimes you need to access only some rows or some columns for our calculation purpose, that we will learn how to access a particular rows or particular columns, that is looking at columns, rows and cells. When you look at this, see print df.head, when I use this command I am getting there are different for example the first column says 0, 1, 2, 3, 4 country, year, population, continent, life expectations, GDP per capita. Suppose I want to get the first row, as we know that the Python counts from 0, if you want to know the first row you type a print df.loc, it is a location, in square bracket 0. When you do that you will get the details which are there in the first row. Suppose if I want to know 100th row, so print df.loc 99, we know that Python count from 0, if you want to know 100th row you have to type 99. So it should be in square bracket, you can see the details in the 100th row. Suppose if you want to know the last row in the data set, so print df.tail n equal to 1. If you type n equal to -1 it will not work, that you will see why. If you want to know the last row, simply type print df.tail n equal to 1, you will get to know the what is the last row. So we will see that. Now we are going to use this command to see the last row. Yes, that is the details about the last rows. Now we can subset multiple rows at a time. For example, there may be requirement we have to select 100th row, first row, 100th row and 1000th rows. For that purpose you type this command print df.loc, you see there are two square brackets 0, 99, 999, we will see what output we are getting. So type print df.loc yes. So we are able to see the first row, 100th row and 1000th row. There is another way we can subset rows by row number by using this command ILOC. Previously LOC, now we are going to use ILOC. Suppose if I type I want to get the second row, if I type print df.iloc1, I will get the details about the second row. Okay. Yeah, this is the details about the second row. Suppose I want to know 100th row by using ILOC command. So go there. Yes, that is the details about the 100th row. You see that if I want to access the last row by using ILOC command, so you can directly type print df.iloc in square bracket -1. So that will be the details of the last row. So what you can do, you can open our Excel file, you can verify what was the detail in the last row and so on. See then important note here, with ILOC command we can pass in the -1 to get the last row, but same thing that we could not do with LOC. That is the difference between LOC command and ILOC command. Suppose we want to get the first 100th and 1000th rows using ILOC command. So we are going to type this print df.iloc 0, 99, 999. Let us see what answer we are getting. Yes, see we are getting first 100 and 1000. So far we have seen subsetting rows, now we will see subsetting columns. The Python slicing syntax used a colon. Colon represent all the rows. If you have just a colon, the attribute refers to everything. So if we just want to get the first column using LOC or ILOC syntax, we can write something like df dot LOC, see colon in square bracket colon comma which column we need to refer to subset the columns. The next slide I am going to show that we are going to subset the columns with the LOC. Note the position of the colon, it is used to select all rows. You see that subset equal to df dot LOC colon comma, I want to see only two columns, that is year and population. So when you type this way, you will get all the rows, only two columns details, that is year and population. We will type this. So when you type print subset dot head, we can get the first 5 rows. So you will see how it is appearing. Subset equal to, subset is object because from the df is the initial object which has all the details. Now I am going to fetch only few columns from the df object that I am going to saved in the name subset. Subset is the object. So all the rows, but I need only year column and population column. So I am going to type, I want to see the first 5 rows. See that I am able to see first 5 rows only for 2 cells, that is year and population. This is the way to get only 2 cells from the 2 columns from the big file. There is another example, subset column with ILOC. ILOC will allow us to use integers, -1 will select the last column, the same thing whatever we have seen in the previously. So subset equal to df dot ILOC colon represents all the rows, then in square bracket 2 comma 4 comma -1, then we can see by using this command, that is a print subset dot head first 5 rows. See that we are able to see the last column and the population column, life expectancy column. You can open your Excel sheet, you can verify whether we are getting the right answer or not. Sometime there is another way for subsetting columns by using the command called range. First we will make a range of numbers. We are going to save that range of numbers in object called small underscore range. So small underscore range equal to list range 5. Print small range, you will get 0, 1, 2, 3, 4. Now this small underscore range object can be used to access that corresponding columns. So if I type subset equal to df dot ILOC colon comma small underscore range, I can get first column, second column, third column, fourth column and fifth column. So we will try this. Small underscore range is an object, we are going to create a range. Suppose we want to see what is small underscore range, so it is up to 0 to 4, that means 1 to 5. Now we are going to subset using that object called small underscore range using iLocation command, df dot iLocation colon small underscore range . You see that here we are able to see, 5 column, that is a country, year, population, continent and life expectancy. So far we have seen subsetting only rows and columns. Now we are going to subset rows and columns simultaneously. For example, using LOC command. So if you type print df.loc 42 country, we can check in the 42 label in country columns what is the cell name. That cell name is Angola. We will try this. We are going to see in that file in 42nd label in country column what value is there. So that is Angola. Yes. We can see what is in the using the same I location, we can see in 42nd label in 0th column. Now we can represent column also with 0th column what value it is. We will see that. You can verify after getting the answer, you can open that Excel file, you can verify we are correctly accessing the cell or not. Print df I location in 42nd label 0th column what is the value, it is Angola. Yes. Next we can subset multiple rows and columns. For example, get the first 100th and 1000th rows from the first, 4th and 6th column. So now we are going to simultaneously we are going to fetch rows and columns and corresponding cells. So print df.iloc 0, 99, 100. Similarly, column label is 0, 3, 5. Let us see what answer. These accessing rows and columns is very important functions, because nowadays data file comes with a lot of rows and lot of columns. We need not use all the columns, all the rows for further analysis. Sometimes we need only a specific rows or specific columns. So these basic commands will help you how to access a particular rows and columns. That will be very useful when we do further analysis using Python. Yeah, this is the value. So that means first row, 100th row, 1000th row, first column and so on. There is another way. If we use the column names directly, it makes the code a bit easier to read in terms of number. Instead of using number column, if you use for representing column, if you use column name, we can easily see what is there. So simply you can type the column name. So we will use this command print df.loc 0, 99, 999, then directly we will type the column name, country, life expectancy, GDP per cap. You see there is a square bracket here that you have to, we'll see that. Life capital EXP. Yes, this is the, because country, life expectation, this is a easy way to, because we cannot remember column name. This was the, not only that, instead of, see, suppose if you put 10:13, that corresponding rows will be displayed. So print df.loc 10 to 13, that means 10th row, 11th row, 12th row, 13th row will be shown, and in columns country and life expectancy and GDP per cap. So we will try this command. That means we can see the range of rows at a time. GDP per cap. You see, we are able to see the 10th row, 11th row, 12th row and 13th row. Okay, next, see print df dot head, we can able to see first 10 rows. In the 10 rows, sometime for each year in our data, what was the average life expectancy? To answer this question, we need to split our data into parts per year, then we can get the life expectancy column and calculate the mean. So, what is happening? There is a command which I am going to use called group by. When you look at the data, it is not grouped. So, when you use this command print df dot group by year and life expectancy and corresponding mean, the mean of the in the year 1952, the mean of the life expectancy variable is 49.05, in 57 51.09. If you look at the data, it is not in this order. So, the group by year, this command is grouping all the values with respect to year. So, we will see what is the answer for this, we will verify this. When you open that Excel file, you see that Excel file will be in some other form. It is not in the, it is not grouped by years, because different years are appearing at different places. So, this command, that is a group by, will help you to group the data in year wise. GROUPY. Group BY. Yes, you see that we are able to get in 1952 the life expectancy was 49 years. You see that when you look at this data, when a year increases, the life expectancy year also increases due to advancement of medical facility available, and the standard of life is also increasing. Now we can form a stacked table. Stacked table is using the group by command. So, you type this multi underscore group underscore variable equal to df dot backslash. See, the backslash represents, to breaking the command we can use backslash, otherwise you can write straight away also, no problem. Df dot group by year, continent, life expectancy, GDP per cap, then we can find the mean, then we will get this output. For that means in 1952 in Africa the life expectancy is 39, in America 53, in Asia 46, in Europe 64. We will try this command. When you type this command, you will get an output that is a stacked table that is very useful for interpreting the whole data set. It is kind of a way of summarizing the data in the form of table. Multi underscore group. You see that? You see that now year wise, it is very useful command. It is year wise 1952, some country, Africa, what was the average year, 1957 Africa, You see that if you look at only the Africa data, 52 to 39, in 57 41, in 62 43, in 67 45. See that we can interpret this way by looking at this table. Suppose we want to flatten this. If you need to flatten the data frame, you can use this reset underscore index method. Just you type flat equal to multi underscore group underscore where dot reset underscore index, then you see now the data is again now it is flattened. The same data set which was in the table form, now it is in the simple ordinary form. So, we will try this command. These things what you are doing in data manipulation, because from the big data file we have to learn these kind of fundamental data manipulation methods that will be very useful in coming classes. So, we are going to use reset underscore index command to flatten that stacked table. See that now we can see first 15 rows. Now it is data is flattened into the normal form. The next one is grouped frequency counts. By using n unique command, we can get count of unique values on the Panda series. So, when you type print df dot group by continent country dot n unique, you can get unique values, that means frequency. Okay, we will try this command, print yes. See Africa 52, America is 25, Asia 33. When you look at the data, again you go to Excel data, you can interpret what is the 52 means, what is the America 25 and so on. Now some basic plot. We are going to consider two things, one is year and life expectancy. So, we are going to create a new object that is called global underscore yearly underscore life underscore expectancy by grouping year and life expectancy with respect to its mean. Then we are going to print it. So, we are going to get two values, one is year, next one is life expectancy, that is a mean life expectancy. We will see this. There is a new object. That object name is called global underscore yearly underscore life expectancy. Yes, you see that year, and suppose if you want to plot it, we will see we are going to plot this data. How we are going to plot it? Simply just that variable that object name dot plot, that automatically takes, this was the output which I got it in x axis in year, in y axis average life expectancy. We will run this. So, what this data says that when the year 1950 to 2000, you see when year increases, the life expectancy also increases. Just we have seen only a simple plot. In coming classes we will see some of the visual representation of the data. We are going to see histogram, frequency polygon, ogive curve, pie chart, stem and leaf plot and Pareto chart and scatter plot. Suppose this is the data. See what is there in east, west, north in column first quarter, second quarter, third quarter, fourth quarter. Suppose the very easiest way is the graph by using, this is called bar graph, bar chart. Bar chart is different regions are labeled as at different colors. Okay. This is a method of visual representation of the data. If we look at this, the eastern side in third quarter there are more sales. Okay. The another way to represent visually the data is pie chart. You see first quarter, third quarter, you look at this in third quarter which is in blue in color, there are more sales. And most importantly the pie chart we can draw, we can get pie chart only for categorical variable. When the variable is continuous you cannot use bar chart, you cannot use pie chart. So the pie chart is used only for categorical variable, that is for only count data. The another one is a multiple bar chart. This is another way to represent the data visually. Another one is a simple pictogram. See this is a frequency table. See next one is a frequency polygon. These figures are drawn from our previous table which was shown in the previous slide. So below 20, around 13, 14, the first this represents frequency polygon. When you connect the midpoint you see that this is called frequency polygon. Then this one is the cumulative frequency. It is not always, you cannot connect the midpoint, we have to be very careful. If the data is continuous then only you can connect this bar with this bar. If the data is not continuous you cannot connect it. Next one is a histogram. The histogram was constructed from the given table. You see the lower limit of the table values is going to in x axis, the frequency is shown in the y axis. You see that this data in continuous data, okay, that was histogram. The purpose of histogram is the histogram will give you a rough idea what is the nature of the data, whether what kind of distribution it follows, whether it is following bell shaped curve, whether the data is skewed right or skewed left. Next one is the frequency polygon which I have shown you. If the midpoint of histogram are connected then that is called frequency polygon, because the frequency polygon is used to know the trend, what trend of the data. The next one is the ogive curve, this is cumulative frequency curve. So what is happening in the for example 20 under 30, the upper limit of the interval is taken in the x axis, the cumulative frequency is taken in the y axis. For example the first interval 20 to 30, so 30 the upper interval is 6, for 40 upper interval is 24, that is marked, because the advantage of this ogive curve is, suppose if I want to know below 60 how many numbers are there, that can be read directly from the ogive curve, that is the purpose of ogive curve. Next one is the relative frequency curve, exactly similar to that. Now instead of actual frequency the relative frequency was taken, okay. The next way to represent the data using Pareto chart. The Pareto chart is having some applications in quality control also. This is to identify which is more important variable. Assume that if you look at this Pareto chart, there are 3 axes, one is frequency, in x axis different name is given, poor wiring, short in coil, defective plug, other. You see there is one more variable that is in terms of percentage. For example, I am a quality control engineer. Suppose my motor is failing so often. I want to know, there are different reasons for failing of that motor. I want to know what are the main reasons due to which the motor fails. So what I have done, first I have got a frequency table, that is due to poor wiring the motor was failing for 40 times, frequency is 40. Due to short in coil, the motor was failed 30 times. Due to defective in plug, the motor was failed 25 times. Due to some other reasons, the motor was failed by say below 10 times. So, the first technique is for drawing this one. First we have to arrange in the descending order of their frequency. So, in x axis that values are taken, then the cumulative frequency is plotted on this axis. For example, how to interpret this table is, you see here this value corresponding this value is 70. So, 70% of the failure is due to only two reasons, that is poor wiring and short circuiting. So, what is the meaning of this one is, if you are able to address these two problems, 70% of the failures can be eliminated. So, the purpose of Pareto chart is to identify which is critical for us. Generally it is called 80-20 principle, 80-20 principle, this is called the Pareto principle, that is 80% of the problems are due to 20% of the reasons. So, similarly here when you look at this, here it need not be always 80, see the 70% of the failures only due to two factors, that is due to poor wiring and short coil. So, this is the Pareto chart. The next one, the scatter plot. The scatter plot is so far what I have seen only for one variable, the scatter plot is used for two variable. In x axis the registered vehicle, in y axis the gasoline sales. So, this says the scatter plot says when the number of registered vehicle is increasing, the gasoline sales also increasing. So, the scatter plot is used to know the trend of the data. Some of the basic principles for excellent graph, one is the graph should not distort the data, the graph should be very simple, it should not contain unnecessary adornments. So much decoration in the graph is not required. The scale on the vertical axis should begin at 0, all axes should be properly labeled, whether it should be x axis or y axis, it has to be properly labeled. The graph should contain a title. The simplest possible graph should be used for given set of data. These are the basic principle of excellent graph. See, when you look at this one, in the left hand side it is a bad representation of the graph. What is happening? Lot of animations, unnecessary pictures. The right hand side, you see it is a simple graph, x axis is taken as year, in y axis it is taken the wage. So, it is showing some trend, but when you look at the left hand side, it is not giving any idea what is happening here with respect to wage. Another one is you look at the left side picture and right side picture, both are the same data, but what is happening when here in the left side picture the scale is 0 to 100, here it is 0 to 25. Just by changing the scale we are able to get different interpretation. You see that when the scale is increased, it look like flat. If you are drawing in smaller scale, you see that it look like there is a lot of variations. So, what is the learning is that we have to use proper scale to draw the picture. The next one is the graphical error, no 0 point on the vertical axis. When you look at the left side the figure, January, February, March, April, May, June, the month is given in x axis, monthly sales is given y axis. But the problem on the left hand side is it did not start from 0. The right side is you see that a small break is given. So that even though 0 to 36 there is no data, you have to make a small break like this, so that we can come to know start from 0. So, this is the right hand side is the right way of drawing the graph. This is the basic requirement. In this lecture what you have seen, we have seen how to access particular rows and columns by using basic commands. Then we have seen the different visualization techniques, different theories of the visualization technique. The next class we will take in some sample data. By using the sample data, with the help of the sample data, we will try to visualize the data by having different tools like pie chart, bar chart, pictogram, Pareto chart or simple graph. Thank you. We will see next class.